Welcome to Study Loop.
So here is an electron of kinetic energy, let me write that as T, of kinetic energy 2.5 kilo electron volts, right? And it is moving uh, along the positive direction of an x-axis, so the velocity is uh, in direction of, let me write that as v and I hat, right? We don't know velocity, we can determine that if you require by using this t, that is v equals to, if we want to find this out, then it is 2t by m by using the energy relation for kinetic energy half mv squared, right? So let's move on to the question again, and says that the electron enters into a uniform electric field of magnitude 10 kilovolt per meter. So electric field E vector equals to 10 kilovolts per meter, and that is in the negative direction of y-axis, so minus j hat, right? And there is a uniform magnetic field to be applied so that the direction does not change, the electron keeps on moving along x, so v equals to what? So for this, to keep the electron moving along x-axis, what we need is the force due to electric field should be equal and opposite to the force due to magnetic field, right? This means that the force due to electric field Fe should be equal to the force due to magnetic field B. So force due to electric field is, this is an electron, right? So it is an electron, so minus QE equals to Q times V cross B. So Q and Q cancel with each other. So electric field E is in G direction, so right? So E times J is in minus J, right? So let me write this as minus J here. Magnitude of E and minus J, and magnitude of E is 10 kilovolt per meter, should be equal to the velocity magnitude V, let me take this out, times I cross B, right? So if I want minus J here, if I want minus J in the right hand side, what should be the direction of B? So I cross what is equal to minus J? So that is the question. Well, that is the thing that you have to consider here is is I cross minus k is equal to J. So this is the relation between cross products. I cross J equals to k, and J cross k equals to I, and k cross I equals to J. So if I want minus J here, so that should be I cross k will give me minus J, right? So B should be in, this implies B vector should be in k direction, right? Now you just need to find the magnitude now, so just write the magnitudes here. So E should be equal to V times B, after the magnitude B comes out of the bracket, and I cross k cancel with minus J, and this gives me B is equal to electric field upon velocity. Electric field upon velocity is what? root under m by twice t. So plug in the values here. The energy, the magnitude of energy is 10 kilovolt per meter. So 10 to the power 3. This will give me volt, right? Root under, what is the mass? Mass of electron is 9.1 into 10 to the power minus 31. And what is kinetic energy? So 2 times 2.5 into 10 to the power 3, right? Now what is the charge of electron? Into 1.6 into 10 to the power minus 19. So if you calculate all this, you get, this comes out to be 3.37 into 10 to the power minus 4 Tesla. So in vector form, what we can write is V vector equals to 3.37 into 10 to the power minus 4, and the direction is k hat. So this should be the magnetic field, so that the electron, stays in the x-axis. Well, this is just the magnitude. If we want these to cancel each other, if we want the magnetic field and electric field to cancel each other, then the magnetic field should be opposite direction, right? The force due to magnetic field should be opposite. So we can just add a minus here so that they cancel each other. We just found out what should be the magnitude of B. So this is minus. Or what we can do is, you can begin from the very beginning that force due to electric field should be, just write negative everywhere, should be negative of magnetic field, right? Equal and opposite, because this should be equal and opposite. So just add minus everywhere here, so that will also give you the same result. So it will be minus k2. Okay. Alright, so this ends the solution for this question. Thank you for watching.